the aluminum and sodium.
Nice. All right. So aluminum would take sodium's place, and sodium would take aluminum's place, right? That's a double replacement. So what are the products?
It would be sodium and chlorine.
Sodium and chlorine. How many chlorines do you need if you bond to sodium?
3.
Sodium's a group 1 metal, right?
Oh, yeah.
So there's a 1 plus oxidation state. So how many chlorines do you need? You crisscross these oxidation states, right?
Yeah.
Chlorine's a 1 minus,
Uh-huh.
so you just crisscross them.
Alright,
So how many of each do you need?
1.
1 of each, right? So we wouldn't write anything, actually, right?
Right.
It would just be NaCl. That's table salt. What's the other thing?
Aluminum and
What's that called?
yeah.
It's called carbonate.
Yeah, that's right.
How many carbonates would you need? If aluminum is in group 13, how many carbonates would you need?
Need 3.
3, exactly. And if carbonate has a 2 minus charge, how many aluminums would you need? 2, exactly. So that's aluminum carbonate. So the question is there a phase change? We started with 2 things that are aqueous, right? They're dissolved in water. And we want to know, is table salt, is that soluble? Yeah, absolutely. So you know from your own common experience, NaCl is soluble. But more importantly, if you look at your periodic table, we're going to search for the anion. The anion's the second thing. So we're going to look for the chlorine. And we see chlorides right here are soluble, except mercury, lead, and sulfur. Right? So that's aqueous. What about carbonates? So you search for this anion, carbonate. Where do you find it? Here or here? Somebody want to help them? First box or second box? Soluble box or insoluble box? In the second one, right, the insoluble box, it says carbonates are insoluble except alkali metals and ammonium. Is aluminum an alkali metal? An alkali metal is a group 1 metal. Is aluminum a group 1 metal? It's not. So is this soluble or insoluble? It's insoluble. So what phase would we put here, Campbell?
Solid.
Solid, right? We're going to put an S. So if you haven't done this already, to help yourself out, if you find something in this box, put an S here, so you know that the phase is solid, right? In this box, if you find something in here, put AQ, that's the phase, right? It'll be dissolved in water. So that's a good reaction. Thanks, Tim. That's awesome.
Good job, Ken.
Okay, so let's work on one additional solubility rule. It's actually kind of complex, but I want you to have this for the rest of the year. These ones are tough. This problem set right here is really hard. There's some new polyatomic ions you don't know, so I'm gonna introduce them to you by giving you the solubility rule for them. All right. So first off, let's do thiocyanate. SCN. The charge is -1. That's called thiocyanate. All right, and that we'll talk about the solubility at the end. So just write down the formula and the name. Put this on your periodic table, or you can put it in your notes first and then transfer it over to your periodic table, whatever you want to do. But this rule, you want to put this on your periodic table in the end, okay? So thiocyanate, sorry, is that not high enough? Is that better? Thiocyanate is SCN -1. It's a 1 minus charge. The next one you want to know is S2O3. That has a 2 minus charge, and that's called thiosulfate.
You already have me put this on my table.
I did?
Yeah.
Good. All right. Then you're all set. And then you want to know cyanide. That's on your periodic table. That's just called cyanide. Very soluble, right? And lethal. That'll kill you. And then cyanate is OCN.
What's cyanate for?
Cyanate wouldn't kill you, but it's a really easy, depending on what you mix it with, to make cyanide from cyanate.
What do you have to mix it with?
Moving on. And then, so SiF6, that's called fluorosilicate. That has a 2 minus charge on it. Fluorosilicate. All right. So all of these are soluble. So they all go in that first box, the AQ box. There are some exceptions I'm going to give you. So these first two are just like the chlorides in that the only exceptions are mercury and silver and lead. All right, so those are fairly simple. They're just like the chlorides. All right, and then this one, the fluorosilicates, the only exceptions are group 1 metals, which is a fairly common exception. You guys probably have seen that a lot, right? At this point, you realize the group 1 metals, they're very soluble. If they're bonded to anything, it tends to make it soluble. So group 1 metals and barium. Cyanate. Look at the similarity in the formula between cyanate and thiocyanate. They're almost identical. The only difference is that you swapped an oxygen for a sulfur, and they're in the same group. So the reactivity is identical, the solubility is identical. Cyanide is just like the chlorides as well. So actually we can expand this little thing to here. So all of these, the only exceptions are lead, mercury, and silver. And this one, the only exceptions are group 1 and barium. Cool. So put that on your periodic table. That'll help you work through this problem set. So you want to do one that's complicated together?
Yeah.
Let's do let's do number 2. All right. So number 2, that's sodium. What's this called? Sodium cyanate. Very nice. Cyanate. And what's this one called? Potassium thiosulfate. Thiosulfate. It's just like think about sulfate. Oops. Think about sulfate. And so that's sulfate, but you're adding an extra sulfur, so they call it thio to indicate that. Thio is the stem for sulfur, the Greek stem. So we're just going to swap positions of this sodium and this potassium, right? The cations swap positions. So we end up with potassium and cyanate and sodium and thiosulfate. So what's the issue here? There's no phase change. So this is actually no reaction. Nothing happens. This thiosulfate, that has a 2 minus charge on it, so you'll need 2 sodiums. So if this were to happen, I'm just telling you how we write the correct formulas. This one is correct the way it is though, because cyanate has a 1 minus charge and potassium is a group 1 metal, 1 plus charge, right? Does that make sense? That one's pretty complicated, but again, they're all those polyatomic ions are all fairly soluble. So group 1 metals usually make things really soluble. Work on this problem set. You can work together. This problem set's due tomorrow, along with the whole blizzard bag, right? So all 3 pages, including the decompositions, due tomorrow. We're going to do decomposition tomorrow together.
Why'd you make such a big blizzard bag?
Well, I only wanted you to do 15 problems, right? So the blizzard bag is supposed to take you about 20 minutes. 15 problems should take you 20 minutes or something. So I didn't want you to do the whole thing. I was just planning on. I actually wanted to be able to work at each of these with you. He did the whole thing because he's a goober and he doesn't read instructions. Yeah. Right. Yeah.
Would you say the solubility for all of the nuanced ones?
Okay, so cyanate, OCN, thiocyanate, cyanide, and thiosulfate. All of those have the same rules as chlorides, which are they're soluble except mercury, silver, and lead. The only one that was different was the fluorosilicate. And the only exceptions to that solubility is just group 1. So it's soluble except group 1.
So, can you tell me why this is not a reaction again?
Yeah. So group 1 metals tend to make them soluble, right?
Right.
And these are all soluble except mercury, lead, and silver. So this is soluble. So is this, right? Sodium makes it soluble. So nothing happened. You started out with 2 aqueous solutions. You ended with 2 aqueous.
Oh,
Okay,
because
so-
they're both soluble. So
No bonds were broken, no bonds were formed.
Okay.
Do we
I
know
don't
this
get it.
problem set?
We'll figure that out tonight.
What's that?
Did you give us the problem set?
Yeah. Well, so you should have it. You had it yesterday. It's the same one. But if you don't have it, I can give you a new one.
Oh, it's just
Yep.
oh, it's on the other side. Okay, cool.
So this problem set's due tomorrow. The homework quiz tomorrow will be right off of this problem set. So if you don't finish this in class, do it for homework.